Hello, my name is Brandon Krumwiede. I'm a physical scientist with NOAA's Office for Coastal Management, located in Duluth, Minnesota, and I serve as the Great Lakes Regional Geospatial Coordinator. Today, I will be providing an update on our Great Lakes benthic habitat mapping project funded through GLRI. To kick things off, I want to just set the stage by explaining the importance of benthic habitat mapping here in the Great Lakes region. To start, I'd like to reference a quote here from Heyman and Wright. Marine environments and their associated biota are dictated by their physical oceanographic and geographic settings at all scales. And so when we look at the complexity and the diversity of our coastal and nearshore environments in the Great Lakes, it's pretty amazing to see the wide range of settings. From the natural shorelines of the Apostle Islands, as you see here in the lower left, to the Chicago skyline in front of the Chicago shoreline there in the center photo. But then what is also interesting is the amount and type of diversity present with our Great Lakes benthic habitats. And here is just one example from South Manitou Island near Sleeping Bear Dunes, showing the extent of Cladophora during a 2016 underwater video data collection. And of course, this is not what we see in all of the Great Lakes, and it reiterates the importance and why we must go out and update the mapping in the Great Lakes Basin. Additionally, these environments are changing over time, and what's remarkable is how quickly they are changing. Here's an example from Illinois Beach State Park, showing the coastal erosion that is evident in the 2008 to 2018 aerial imagery, and of course, the change that we see in the nearshore environment as well, in the picture to the far right, also showing the difference between digital elevation surfaces from 2018 to 2008. You can see areas highlighted in red showing erosion that has occurred along the shoreline, but you can also see erosion that's occurring out in the water as longshore currents travel from north to south and create bed scour just south of this water intake pipeline. You can also see other man-made features present here. For example, this road that actually existed back in the 1970s, but now is located in about 10 feet of water. And so it's important to understand how this nearshore environment is changing in responses to changes in water levels and changes to sediment delivery and other factors that influence the dynamic nature of our coastal and nearshore environments. To get a better understanding of these changes and what is out there, what is underneath of the water, in 2019, NOAA, together with several other agencies, worked to develop a GLRI project focused on collaborative benthic habitat mapping in the nearshore waters of Lake Superior, Michigan, and Huron. Just as an overview, showing here the funding levels that we have received to date for this project work. You can see that we started kind of small to start, just to see if the work could be done effectively. And so in FY19, we requested $500,000. And for the next couple of years, we, kind of took a few smaller amounts of funding. But for FY22, we scaled up. We requested a larger amount of sums to complete this work. And of course, we were accepted to receive those funds and scale the work accordingly. And I'd like to highlight that it's not just NOAA's Office for Coastal Management that's doing this work. We are working collaboratively with the Great Lakes Environmental Research Laboratory, the National Centers for Coastal Ocean Science, or NCOS, as I mentioned, OCM, but we're also working with the Office of Coast Survey, the Office of National Marine Sanctuaries, as well as other federal agencies, including the National Park Service, the USGS, and state agencies, including Michigan Department of Natural Resources, Wisconsin Department of Natural Resources. And I'd like to highlight here too that this is the partners that we've worked with to date. That's not to mean that we won't work with others in the future. The goal here is to increase our modern understanding of the amount of types of aquatic habitat present in each of the lakes, Lake Superior, Michigan, and Huron, by increasing the number of acres that are mapped and classified for species that benefit under Focus Area 4. These species include lake sturgeon, lake trout, perch, walleye, but then also too the habitats that they're associated with. And just to reiterate the past project work and by the numbers here to show the amount of area and how we're starting to scale up, in FY 1920, with the funding that we received, we were able to map out approximately 78 square kilometers using multi-beam sonar along the western side of the Bayfield Peninsula and Apostle Islands. In FY 21, we were able to almost double that work with multi-beam, including 142.4 square kilometers of multi-beam sonar. And we also leveraged bathymetric LiDAR for these data collections. And with that work, we were able to collect an additional 129.5 square kilometers of LiDAR. And again, this is around the Sleeping Bear Dunes, Good Harbor Reef, and Manitou Passage geography. As I mentioned, we are scaling up this work, but our work is focused primarily in what is known or classified as the nearshore environments under the Great Lakes Restoration Initiative and the Coastal Working Group of GLRI under Focus Area 4, Habitat and Species. So that 0 to 80 meter depth band is the focus for this work moving forward. And just to show you here, and I know it's a little hard to see with this particular map, but we've also broke it out into the 0 to 15 meters, 15 to 30 meters, and 30 to 80 meter water depths. And the reason that we're looking at those particular water depths is based on the technologies we're using to collect data. Ideally, we should be able to collect anything that's 0 to 15 meters with bathymetric LiDAR, but that doesn't always hold true. For example, in Lake Erie, because of the high turbidity in the nearshore environment, it's almost impossible to get bathymetric LiDAR any deeper than, say, 3 to 5 meters offshore. And so that 15 to 30 meters is a transition zone where we have been successful in some parts of Lake Michigan, for example, to collect bathy LiDAR out even as far as 30, 35 meter water depths. But more importantly, those areas that are highlighted in the darker shades of blue, and again, sorry, they blend into that black with the imagery here, that 30 to 80 meter water depths, those are the areas ideally suited for multi-beam data collection in the Great Lakes. And so for each of the lakes, what we've further refined this as a split between 0 and 25 meters or 25 to 80 meters to really highlight, where could we leverage bathy LiDAR technologies versus multi-beam data collection technologies. And so you can see those remaining areas in the Great Lakes region. And so what I should mention as well here is these numbers reflect the latest in terms of new bathy data collections at a higher spatial resolution. And so just taking one lake, for example, here, Lake Michigan, we can see that just over or close to 6,000 square kilometers remain in that 0 to 25 meter water depth, whereas there's over 14,000 square kilometers in the 25 to 80 meter water depth, for a total of over 20,000 square kilometers of 0 to 80 meter water depths that remain to be collected within Lake Michigan. And so if we look at each of these lakes, Lake Superior, Michigan, Huron, Erie, and St. Clair together, as well as Lake Ontario, in total, and again, prior to our FY22 field season, we have over 48,000 square kilometers remaining for new benthic habitat mapping and high resolution bathymetry data collection. So as part of this project, it's not only about acquisition, but also doing validation work, product development, and of course, distributing the benthic habitat classification products. And so this is a breakdown of our budget currently as we continue to work through this project. So there's a little bit off the top for administration, and again, that's being led by the Office for Coastal Management. But you'll see some big chunks here, especially 35% for multi-beam data acquisition. Again, that's working with GLRL and the Office of National Marine Sanctuaries. We're also working very closely with the Office of Coast Survey and sending funding their way to support some of the NRT or Navigation Response Team work in the Great Lakes region and other collection areas that they are interested in here in the region as well. 28% is associated with LiDAR acquisition, and then 15% of the budget approximately is associated with validation work that's being led up by NCOS. And then the remainder of the budget is looking at product development. So taking the multi-beam data, and the LiDAR data and creating the coastal marine ecological classification standards geospatial products using those data together with validation data, including drop cameras, PONAR, and any other empirical measurements that we can take of the substrate or the biotic side of the wheeled house there, and producing a geospatial product that actually maps out the substrate, the biotic, and the geoform components under the CMAX classification standard. And again, we set aside some of the funding for data distribution. And part of that work is actually looking at, how do we go about making sure people can discover these products after they've been created, whether they're on NCOS's website, NOAA OCM's website, or other resources here in the Great Lakes region. I also want to highlight that, well, right now, a lot of our budget is focused on acquisition. In the out years here, we anticipate that this will decrease in the out years, especially as we get more and more new areas collected, but will require additional validation work in the future. And just to, based off of our current acquisition costs, this is just a graph here to show our potential collection areas by fiscal financial cycle, and of course the cumulative area over time that can be collected from the start of the project back in FY19 and looking forward here to what we've put forward in FY23 and 24 through GLRI. Ideally, we're collecting over 11,000 square kilometers of new data. And so this is a really important piece in contributing to the work under Lakebed 2030. And so I'm just going to step through each of these acquisition areas and kind of show you what has been completed, what areas, when we talk about being mapped, what does that look like? And of course, the other thing I want to highlight here too is that this is really heavily partner driven, based off of the needs that we've heard from either state partners, tribal partners, other federal agencies, weighing that all together and identifying the suitable areas for collection in each fiscal year or field season. And so here's just one example, like I said, off the western side of the Bayfield Peninsula, where each of these geographies highlighted 1, 2, and 3 were the priority areas identified by partners to help fill in some of the data gaps. And so you can see this exists between Sand Island and the Apostle Islands and Bark Point along the main line, or excuse me, along the main shoreline. And so for this particular data collection, again, we worked with NOAA GLURL as well as sanctuary staff to go out and do data acquisition on the RV Echo on loan from the National Park Service, actually, to do this data collection. And so what you see on the right is actually the available bathymetry to date, as well as there is backscatter data. And I'm also happy to announce that NCOS has been able to complete the classification of the biotic and substrate components under CMX for this particular location. And so all of these data sets are publicly available and accessible through NOAA's resources. Another big project area for us was Sleeping Bear Dunes in 2021. I'm really excited about this particular project because it does build upon some of the past work we've done at South Manitou Island. And so just highlighting here what the area looked like in terms of high resolution bathymetry in the Sleeping Bear Dunes and the Manitou Passage geography. This is what it looked like before the 2021 field season. And after the 2021 field season, this is a combination of the bathy lidar collection areas. Highlighted here is one particular location, as well as here, anywhere basically near the islands or the mainland. And then, of course, the data collection work completed by GLURL and Sanctuaries folks, excuse me, north of the Good Harbor Reef location, actually filling in a known data gap here on the southern portion of Good Harbor Reef. And a very large geography here actually collected by the RV Laurentian. And so this has been phenomenal data collection work and helping to get a better understanding of what's happening out here at Sleeping Bear Dunes. And so just to zoom in a little bit and highlight what we are starting to see with this newer data, I want to mention some of the work that Jamie Hoover has been doing in terms of the geomorphon classification and, the geoform, not geomorphon, the geoform component classification and substrate classification here at South Manitou Island and the Sleeping Bear Dunes geography. And so what you're seeing on screen right now is the existing 3-meter digital elevation models available through the lake level viewer. But what's really cool is you see this area right here, and what Jamie has identified these as complex as slide areas. And this really popped out. And our biggest question is, well, how big is this? Like, we see it kind of tailing off here to the north, and we can see some of these larger features here just along the shoreline. And so with the new data collection, it's quite impressive. Here you can see actually that this extends very far off into deeper water areas here. And this is just incredibly more detailed than what we've had previously in this geography, and really helps to explain the geomorphology as well as the geology of this particular location. And so these are the new visuals, I guess you can say, of what we're seeing with the new data when it's fused together with some of our existing data. And I just want to highlight again the additional coverage that's been provided and understanding, basically what's out there, what's underneath the water surface. And so again, here you can see the existing high resolution bathymetry and some of the nearshore topography. And when we bring in the new data sets, you can see we've got additional coverage here of the reef structure north of Good Harbor Reef, some of the deeper water environments here associated with the channel between that north reef structure and the mainland. As I mentioned previously, we've filled in this gap here around south of the Good Harbor Reef geography. But then what's really interesting here too is from the mainland extending out to North Manitou Island, some of the features that we see here. And so just to highlight, I want to zoom in on this particular location. This is where we're starting to see some of these subaqueous longitudinal dune features associated with the currents that move through Manitou Passage. And so just really incredible the level of detail that we are now able to see with this new data. And our work continues. For 2022, we received some of our early funding under GLRI, and there was 2 geographies identified for data collection in the 2022 field season. This includes data collection east of Madeline Island and Michigan Island on the eastern side of the Apostle Islands geography, as well as a portion of Washington Island here and Door County Peninsula in Lake Michigan. And so I'm happy to report that excuse me, I should back up. The data collection around Washington Island and Door County is actually being collected using bathy LiDAR. And the work off of Madeline Island and Michigan Island is actually being collected through multi-beam sonar, again, being led by NOAA GLERL and Sanctuary staff in that data collection effort. And so I just want to report out that, as I mentioned, the bathy LiDAR collection is complete. Working with our contractor on this, Dewberry, what was really interesting with this field season is they developed this on-screen dashboard that you're all seeing here that allowed us to see day in and day out the collection effort as it was underway. So they'd go out, collect during the day, come in, download the data, and we could see how much area was collected or how many flight lines were completed for that given day. And then, of course, by being able to look at the data on the fly like that, we could see any issues that might be present within the data. And if a reflight was necessary, they would be able to identify those flight lines that would be needed for a reflight. And so this has just been really nice to have on the fly or almost near real time data acquisition information to share with partners and keep us up to date on the work at hand. And so again, just highlighting here the existing high resolution topography and bathymetry that we had prior to that work. And this is the draft new coverage that was provided. I do want to highlight, though, that not everything was 100% wall-to-wall coverage. What you're actually seeing here in the further offshore, where it's kind of this yellowish, limeish color, that's actually the top of the waves. That's not actually bathymetry that you're seeing there. And so you can see where we are starting to reach the depth limitation of the LiDAR. Again, it's about that 30, 35 meter. I'd have to go back and look to see exactly what was our maximum depth collected. But that's also to point out too that we are still under review of this data and anticipating QA/QC to happen within the next couple of months of the final data products. And so we're just happy that we are expanding our coverage and collecting new areas of the Great Lakes using bathy LiDAR. As a lot of people are familiar with the work that the National Coastal Mapping Program and Javeltex have completed here in the Great Lakes, with our collects, we're hoping to expand that coverage further outside of where they typically operate here in the Great Lakes region. And I don't want to take anybody's thunder. I know that there's going to be some presentations on the work that's being done around the Apostle Islands here, but this was provided to me by by John Bright, showing the new coverage that they've been able to collect this field season. And so we're really excited about all the work they've been doing in partnership and collaboration with us on this project, and really looking forward to seeing this data once they can get it to us. And so I just wanted to provide an overview map of where we've been working from FY19 to FY22 to date. And so any of the pins that you see in green are where we've had completed project work to date. So again, the Apostle Islands there on the western side of the Bayfield Peninsula, Green Bay, the Western Lake Michigan, that has actually been completed by NCOS. Some work down at Illinois Beach completed by actually the Army Corps of Engineers together. I worked with Molly Reef on some of that work. And then Eastern Lake Erie, we've done some preliminary CMEX classification there, the biotic and the substrate components. But again, you can see a white pin there at South Manitou Island and Sleeping Bear. That's some work that we're anticipating with the National Park Service. And then also highlighting some of the work in Thunder Bay that NCOS has been leading up as well. And I'm sure a lot of you are saying, well, wait, what about Lake Erie and Lake Ontario? And so I know that, again, there are going to be several presentations at Lakebed 2030 this year, highlighting the work of the Thomas Jefferson. And we've held off on doing any data work in Lake Erie and Lake Ontario until we see what has been completed by the missions performed by the Thomas Jefferson and the navigation response teams in those two lakes. But what I am happy to share, is the work that OCS has led here in the Great Lakes. I am very appreciative of the level of effort and work they have now focused on the Great Lakes region. And our partners here, especially our state partners, are super excited about the new data collections. And so, again, not to steal anybody's thunder, but looking at example Lake Michigan and the new data collected there, as well as Lake Erie. And I know that as the Thomas Jefferson heads out of the Great Lakes, they're hoping to do some data collection in Lake Ontario, and we look forward to seeing that data as well. And last week, I was actually at the Great Lakes Coastal Zone Managers meeting that was held here in Erie, Pennsylvania. And so, of course, couldn't resist putting this in my slideshow for them. But it's really impressive to see the data that has been collected by the Thomas Jefferson and OCS. It's really helping us to get a better understanding of what each of these Great Lakes bottoms look like. And so, again, we're looking forward to being able to use this data for the coastal marine ecological classification standard mapping that we're doing, and looking forward to the future work as well. And so with that, I just want to say, stay tuned. What I've put up on the screen here and what's been made available through our partners within the Office of Coast Survey is showing here where they've done past data collections highlighted in gray, but also where they've done work again in 2022 here in green, what has been captured or hoped to be captured. And there's two big geographies I want to highlight here, extending from north of Milwaukee down towards Chicago and around. These were priority areas that we had identified through our Benthic Habitat Mapping Working Group. And working together with Martha and others at OCS, they said, hey, we can put those into our system as high priority areas as well. And so we really look forward to any data collection efforts that OCS will be leading in those geographies and helping to fill that nearshore and coastal bathymetry gap that exists. And so lastly, I definitely want to hear from each of you that are attending and watching this presentation. What we would like to hear is which areas are important to you and your partners. This map actually shows the Great Lakes Spatial Priority Study from 2021, showing the habitat mapping and characterization priority. And so you can see a couple of hotspots, again, including the Apostle Islands, Green Bay, but also eastern portions of Lake Erie and Lake Ontario. And you'll see here a couple of red outlines highlighting some of our GLRI Benthic team areas of interest to date. And so certainly if there are areas of interest that you don't see listed here, please reach out to us. We definitely would be interested in incorporating them into our data collection strategy and acquisition moving forward. And if there are any questions, or again, if you'd like to let us know which areas of interest are to you, please feel free to email me here at brandon.krumwiede@noaa.gov. And if there are any questions, feel free to email those to me as well. And so definitely looking forward to next year and the years after that with this project. And so if there are any other ideas or thoughts out there, as always, please feel free to share those with me. Thank you.